Hi guys, welcome to my science channel. This is episode 3 and today we'll be talking about cycloalkanes. But before we start today's class, do well to subscribe, share with your friends, and then you may also comment at the end of today's class. Cycloalkanes. So today we're talking about what? Cycloalkanes. A hydrocarbon that contains carbon atoms joined together to form a ring is called a cyclic hydrocarbon. Remember, in our first class, we talked about what? Hydrocarbon. And we said hydrocarbon simply means carbon and what? Hydrogen. We also talked about saturated hydrocarbon as hydrocarbon with what? Carbon-carbon single bond in their formation. But today, we'll be talking about a kind of hydrocarbon that are in their what? Cyclic form. So, hydrocarbons or organic compounds in which their carbon-carbon are joined in a form of ring form are called what? Cyclic hydrocarbon. So, when all carbons of the ring are saturated, that particular hydrocarbon is called a cycloalkane. You should be able to differentiate a cycloalkane and a cyclic what? Compound. If the carbons are joined together in a ring form, we call them what? Cyclic compounds. But a kind of cyclic compound that is saturated, we call that what? Cycloalkanes. So today we'll be talking about cycloalkanes, and basically we'll be looking at how to name these cycloalkanes, the IUPAC nomenclature of cycloalkanes. So we said something like this. If we have, this is CH3, okay, should be 2. We have CH2, 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 and this. If you check at this compound, look at this compound very well, you will see that it is in a form of what? A kind of ring form. A kind of what? Ring form. It is no longer what? CH3, like the normal straight chain that you know. It is now what? CH2. So what you do is that you do the same thing by counting the number of what? Carbons in this structure. We have 1, 2, 3, and what? 4. From our first class down to our second class, we know that 4 carbons actually means what? Butane. So this is actually what? Butane. But it is not the normal butane that we all know in our straight chain. Rather, this is the cyclic what? Butane, because it is in a what? A ring form. So we call this cyclobutane. This is what? Cyclobutane. Why is it cyclo? It is cyclo because it is in a ring form. And cyclobutane. Cyclobutane, yeah. So we call this cyclobutane. It is called cyclobutane because we are having 4 carbon atoms in this structure, and the structure is in a kind of what? Ring form. So we have basically just 2 rules here. I only brought out these 2 rules because I know that by now we should be able to know all the rules that govern IUPAC what? Nomenclature. But apart from those rules, these are the extra rules we need to know, join together with what we know already. To name a cycloalkane, prefix the name of the corresponding open chain with what? Cyclo. That is what we did here. We prefix this compound, this structure, with the name what? Cyclo. We already know that this is butane. 1, 2, 3, 4. It is butane because it has what? 4 carbon. But this kind of butane is in a kind of what? Ring form. And because of that, we prefix it with what? Cyclo. So whenever we are naming cyclic compound or cycloalkane, what we do is to prefix the name of that compound with what? Cyclo. And then there is no need to give the ring a number if there is only one substituent. So if you see a cycloalkane and there is just one substituent on the cycloalkane, you don't need to do what? Number. You are only allowed to do your numbering when we have more than what? One substituent. We are going to know how to use these rules by answering these questions, by naming these cycloalkanes here. It's very simple. If you can name your normal alkane, either the branched or the straight chain, then you can actually know how to name this cycloalkane too. It's very simple. You are going to use your pre-knowledge of the nomenclature of normal hydrocarbon, the straight chain hydrocarbon, and the branched chain hydrocarbon to name this. Only what you have to do, remember, you prefix it with what? Cyclo. And then you also count the number of what? Carbon atoms. Let's do that here. How do we name this cycloalkane? The first thing we are going to do is to count what the number of carbon atom in the cyclic compound. In this ring form now, we count the number of what? Carbon atom in the ring form. We have 1, 2, 3, 4, and what? 5. So the ring compound here has what? 5 carbons. And 5 carbons stands for what? Pentane. So we already know that this is what? Pentane. But it is not the normal pentane that we all know. It is the cyclo what? Pentane. Because it is in the cyclic what? Form. How about the substituent? Let's go to the substituent. We have 1 and we have what? 2. We have 1 and 2. Okay, let's take our red marker. And then we have another one here. Alright. First carbon, second carbon. 2 carbons stands for what? Ethane. So this is the ethyl group. We call this what? The ethyl group. From our alkyl, like we said in our first class. And this is just 1 carbon for what? The methyl. We have 2 carbons for ethyl, and then we have 1 carbon for what? For the methyl. So if you look at this structure very well, you see that the methyl group is on the first carbon of what? The ethyl group. So we are having the methyl group on the first carbon of what? The ethyl group. How then do we name this compound? Alright. Because we are just having one substituent, we are not going to number the cycle what? Alkane. Only number this. So we have 1 bracket 1 methyl, that is methyl, ethyl, and then we close our brackets, cyclo, pentane. We have 1 methyl, ethyl, cyclo what? Pentane. Why? Because we are having our methyl group on the first carbon of what? Our ethyl. And then the name of this ring structure is what? Cyclopentane. Why is it cyclopentane? 1, 2, 3, 4, 5. 5 carbon. Very simple. So this is how we name what? Cyclopentane. Let's go to the next structure. How do we name this compound here? How do we name this compound? We have 3 substituents on this particular cycloalkane. We have substituent here, and substituent here. So numbering will be very, very essential in naming this particular structure. Why? Because we have more than 1 substituent. So we have the methyl here, and what? The methyl here. We have 3 what? Methyl groups on this particular what? Compound. So the first thing that will prick our mind will be, what is the name of this particular cyclic compound? So we have 1, 2, 3, 4, and 5. 5 stands for what? Pentane. So this is what? Cyclopentane. The next thing that will be our interest will be the substituents. We have 3 substituents. So if we are numbering this compound, if you number it this way, let's use our red. Alright, let's number this compound this way. We have 1, 2, 3, 4, and 5. Apart from that way, we can also number it this way. We have 1, 2, 3, 4, and 5. There are other ways we can still number what? This particular compound. But how do we know the best numbering format? How do we know the best numbering format? Alright, if we number it this way, 1, 2, 3, 4, and 5. Our first substituent will be on carbon 1. Our second substituent will be on carbon 1. And our last substituent will be on what? Carbon 2. Let's add these numbers together. 1 plus 1 plus 2 gives what? 4. That is when we are numbering this way. How about numbering this way? Our first substituent here will be on what? Carbon 1. Our second substituent will be on carbon 2. And our last substituent will be on what? Carbon 2. Let's also add this number. 1 plus 2 is 3. 3 plus 2 is what? 5. 5 is greater than what? 4. But we are actually interested in what? The lower number. So we'll go for what? 4. So we are going to cancel this other numbering. This one, yes, this, and this. So we'll go for this numbering pattern because this numbering pattern is giving the substituent the lowest what? Number. What then would be the name of this cycloalkane? Alright, we have how many methyl group here? 1, 2, 3. 3 stands for what? Tri. We have the first methyl group on carbon 1, the second methyl group on carbon 1 again, and the last methyl group on carbon what? 2. We have 3 methyl group. 3 stands for what? Tri. We have tri. The substituent is what? Methyl. And then the longest chain, 1, 2, 3, 4, 5. Cyclo what? Pentane. Cyclopentane. So the name of this compound would be 1, 1, 2, trimethyl cyclo what? Pentane. Why? Because we have the first methyl group on carbon 1, second methyl group on carbon 1, and the last methyl group on what? Carbon 2. 3-methyl, tri-methyl, and then this is the cyclo what? Pentane. 1, 1, 2, tri-methyl what? Cyclopentane. Very simple. This is how we name what? Cycloalkanes. Let's go to the next structure. I know you think it's somehow complicated, but if we follow the rules, it is also what? Very simple. Let's do our numbering. Let's use a red marker. I love using red marker for numbering. This is 1, 2, 3, 4, 5, and 6. Okay, let's use another pattern to number so we know the best way of numbering. It's very easy. Yeah, let me use this. Let's take it like this: 1, 2, 3, 4, 5, and 6. So we are going to count and know the best method to use. If you are taking this way, 1, 2, 3, 4, 5, and 6. The first substituent will be on carbon 1. The second substituent will be on carbon 3. And the last substituent will be on what? Carbon 4. 1 plus 3, 4 plus 4, 8. Alright, let's go for the red marker. If we are numbering this way, the first substituent will be on carbon 1, the second substituent will be on carbon 2, and the last substituent will be on what? Carbon 4. 1 plus 2, 3. 3 plus 4, we have what? 7. So we are going for the what? For the red, because 8 is greater than what? 4. 8 is greater than 7. But our interest is in the lower number, which is 7. Therefore, let's erase this, yeah, Erase this. Erase this. Erase this. Alright. Get a black marker. Do this very well. Do this very well. What then will be the name of this compound? Okay. We all know that in nomenclature we are supposed to name in alphabetical order. This substituent here is the ethyl substituent. 1 and 2. It has 2 carbons. So this is ethyl. Why this substituent has just 1 carbon, which is methyl. But in our alphabet, E comes before N. So we'll start with this. The ethyl is on carbon 2. Therefore, the name of this compound will be, we have 2 ethyl. Alright, then you give your hyphen. We have 1. The first methyl is on carbon 1. Put your compound. The second methyl is on carbon 4. And because we have 2, it will be dimethyl. What is the name of the cyclic compound? 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. 6 stands for hexane. But because it is a cycloalkane, we call it cyclohexane. Hexane. So the name of this compound is 2-ethyl 1,4-dimethyl cyclohexane. Why? Our ethyl is on carbon 2. Our first methyl is on carbon 1. Our second methyl is on carbon 4. And because there are 2 methyl groups, we put we put di. Di stands for 2. The name is 2-ethyl 1,4-dimethyl cyclohexane. Wow, also very simple. Okay, we have more 3 compounds in here. Alright, let's name this compound. Though we are talking about cycloalkane, but we should also have this in mind that while naming organic compounds or alkane, what we should recognize first should be the number of carbon atoms. We should always count the number of carbon atoms, always to know the longest chain before we give our naming. Alright, we have 1, 2, 3. This 3 stands for propane. So this is a cyclopropane. Propane. Alright, we also have methyl group here, and we have another group here. So let's look for the longest chain. Let's look for the longest chain, so we don't get confused. We use our red. Let's look for the longest chain. We have, this is 1. Yes, this is 2. This is 3. This is 4. Are we getting it? Alright, let's count it again. Let's count it again. Because we are having 2 cyclohexane. So we have to be very careful. We have the methyl group here is 1. We have another carbon here. Another carbon here is 2. We have carbon here, 3. We have this carbon here, this carbon, 4. And we have this carbon, 5. So if we are numbering this way, we have 1, 2, 3, 4, and 5 carbons. But if we are considering this cycle, we just have 1, 2, 3, 1, 2, 3, which is just 3. But our interest is in the number of carbon atoms. Our interest is in the longest chain. So we are going to go for the longest chain and not for the cyclo. The cyclo will be our substituent, while the longest chain would be the name of the compound. What then would be the name of this compound? We have our first substituent here, cyclopropyl on carbon 2. We have our second substituent here, another cyclopropyl on carbon 3. So the name of this compound will be 2. Alright, let me use the black marker. 2, 3. Then we're having 2 what? Cyclopropyl. Okay, let's use capital here. Cyclopropyl. What's the longest chain? 1, 2, 3, 4, 5. 5 stands for what? Pentane. Please do not be confused. Whenever we are naming organic compound, or whenever you are naming organic compound, you should always consider the longest what? Chain. Either you are talking about alkane, alkene, cyclo compounds. Always consider what? The longest chain. And that is what we did here. We considered the longest chain, which is what? Pentane. Because the longest chain is pentane, all other structures or compound would be what? Our substituents. 2,3-dicyclopropyl pentane. This is cyclopropyl. This is cyclopropyl. There are 2. That's why we use what? Di. The first cyclopropyl on carbon 2. Second cyclopropyl on carbon what? 3. 2,3-dicyclopropyl pentane. Alright, let's name this other compound. Wow. Okay, we are having 2 different cyclo compounds here. We have 1, 2, 3, 4, 5, 6. This is cyclohexane. And then we have 1, 2, 3. Cyclo what? Propane. Alright. Which of them will be the substituent? It will be what? This. We are going to use this as the substituent. Why? Because this has the highest number of what? Carbons. 1, 2, 3, 4, 5, 6. So this is the longest what? Chain. On this cyclohexane, we have this. Let me use red. Yeah. I love using red to number. On this cyclohexane, we have carbon 1, carbon 2, carbon 3, and carbon what? 4. On this cyclohexane, carbon 1, 2, 3, and 4. So this is also another what? Substituent. 4 stands for what? Butane. So this is like butyl. We are having butyl substituent. We also have what? Cyclopropyl what? Substituent. Sound amazing. What then will be the name of this compound? We have to be very, very careful while naming, so we don't get it wrong. This cyclopropyl is on carbon number what? 4 of this butyl. Listen again. This cyclopropyl is on what? Carbon number 4 of this what? Butyl. So, how do we name this compound? We name it this way. Open your brackets. Sorry. I will always use a black marker too. Yeah, always a black marker. We have 4 cyclopropyl butyl. Then we'll close our brackets. Why are we closing the brackets? Because this 4 cyclopropyl is on what? This cyclopropyl is on the 4th carbon of this what? Butyl. It is not for this. It is not for the cyclohexane. It is what? For this butyl. That is why we are closing this bracket. 4 cyclopropyl butyl. Our cyclopropyl is on carbon 4 of what? Butyl. And then we will bring out this now. This is cyclo what? Hexane. Cyclohexane. Why are we not numbering this cyclohexane? Because it has just one substituent. It has just one substituent. Just one substituent. Just one substituent. This cyclohexane has just what? One substituent. And then on this one substituent, we have another what? Substituent on carbon 4 of this one substituent. And that is why we are putting this in brackets. and then this is alone cyclo what? Hexane. Alright. Then I'm seeing our master down. Wow. Looks like a human being. Looks like a what? Human being. Some will be like, how? Is this a compound? Can this be actually named? How then do we name this? Students get confused. Students get afraid when they see complicated structures. But I don't think there's any structure that is complicated up to the point that you cannot name. Only what you need to do is to follow all the rules that you need to follow. By following the rules, then you'll be able to name any compound at all. Alright. In this compound, we are having the head. The head of this young man here, Mr. B. Let's call this man Mr. B. The head of Mr. B is what? Cyclohexane. Or let's put it cyclohexyl because it might end up being the substituent as I'm seeing it. Hexyl. It is not the longest chain, so let's call it cyclohexyl. Mr. B has cyclohexyl as its head. Alright. It has legs and what? Hands. So the next thing we are going to do is to look for what? The longest what? Chain. Let's use our red marker to look at. Let's look for the longest chain. Alright. Let's count this way. Let's number it this way. 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7. So if we number it this way, we'll be getting what? 7, which is heptane. I think we can also number this in another way. We can also number it this way. 1, we have 1 here. We have 2 at this point too. We have 3, we have 4, we have 5, we have 6, we have 7, and we have 8. Wow. So we are going to follow this because this is giving octane, while this is giving what? Heptane. So we follow this. This is the longest chain. Let's do away with this. Let's erase this. Let's erase this. Yes, so we erase this. Okay. So we have octane has what? Has the longest chain. Octane. The next thing would be going for our substituents. So we have cyclohexyl as a substituent. Then we also have this as a substituent. This substituent here, let's count. This is 1, 2, and what? 3. 1, 2, 3 stands for what? Propyl. Propyl. And then on this propyl, we have 1 and 2. We have methyl here and methyl here. So we have 2 methyl on the second carbon of propyl. So this will be what? 2, 2 dipropyl. That's what this. We are looking at the substituents now. So we also have cyclohexyl on what? Carbon 4. This is another substituent. We are having 1, 2. This is another one substituent. We also have 2, 2 di what? Methyl. So here we have 2, 2 dimethylpropyl. And here we have what? 2, 2 dimethyl. So what then would be the name of this compound? Let's get the name of this compound. Okay. We have 4. Which is this 4? 4 what? Cyclohexyl. 4 cyclohexyl. We've gotten that. Okay, let's go to the next substituent, which is this. Okay, open a bracket. 4 also, bracket what? 2, 2 dimethyl. 2, 2 dimethyl what? Propyl. We close our bracket. Let's go to the next substituent, which is this. We have what? 2, 2 dimethyl also. We have 2,2-dimethyl, and then we have another substituent here. This is 1, 2, 3, 5 propyl, 5 what? Propyl, and the longest chain is what? Octane. Let's explain this again. We have 4 cyclohexyl. This cyclohexyl substituent is on carbon 4. We have 4,2,2-dimethylpropyl. On this carbon 4, we have a substituent. And what is the substituent? 1, 2, 3. Propyl substituent. On this propyl substituent, we have 2 methyl. We have 2 methyl group on carbon 2 of the propyl substituent. And that is why we said 2,2-dimethyl propyl. This 2,2-dimethylpropyl is on carbon 4 of the longest chain. Apart from that, we also have 2,2-dimethyl. That is here. On carbon 2, we have what? On carbon 2, we have another 2 methyl group, 2,2-dimethyl. And then finally, we have about 5 propyl. On carbon 5, we have another propyl. The longest chain is octane. Therefore, the name will be 4 cyclohexyl, 4,2,2-dimethylpropyl, 2,2-dimethyl, 5-propyl octane. It's a very long name. So you can actually see with me that naming compounds is very simple. Only what you have to do is to follow the rules carefully. You don't jump into naming compound from anywhere. Check your longest chain very well, look at the substituents, and then you will name any compound in organic chemistry. So in today's class, we've learned how to name alkanes, cyclic compounds. We also know the rules that to name a cyclo, you have to prefix the name with cyclo. Then there is no need to give the ring a number if there is only one substituent. We've also known how to name some of the some cycloalkanes here. And I'm very sure that if you have been following me from the starting of this class to the end, you should be able to name any cycloalkane at all. Thank you. Make sure you keep on following our channel. In our next episode, we'll be talking about bicycloalkanes. Thank you. So Mr. B has cyclohexyl as its substituent. So the next thing we are going to do is to look for the longest chain. Let's use our red marker to do that. Let's look for the longest chain. Alright, let's come this way. Let's number it this way. 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7. So if we number it this way, we'll be getting 7, which is heptane. I think we can also number this in another way. We can also number it this way. 1, we have 1 here. We have 2 at this point too. We have 3, we have 4, we have 5, we have 6, we have 7, and we have 8. Wow. So we are going to follow this because this is giving octane, while this is giving heptane. So we follow this. This is the longest chain. Let's do away with this. Let's erase this. Let's erase this. Yes, so we erase this. Okay. Let's use our black. So we have octane has the longest chain. Octane. The next thing will be going for our substituents. So we have cyclohexyl as a substituent. Then we also have this as a substituent. This substituent here, let's count. This is 1, 2, and 3. 1, 2, 3 stands for propyl. Propyl. And then on this propyl, we have 1 and 2. We have methyl here and methyl here. So we have 2 methyl on the second carbon of propyl. So this will be 2 2-dipropyl. That's for this. We are looking at the substituents now. So we also have cyclohexyl on what? Carbon 4. This is another substituent. We are having 1, 2. This is another substituent. We also have 2,2-di-methyl. So here we have 2,2-dimethylpropyl, and here we have what? 2,2-dimethyl. So what then will be the name of this compound? Let's get the name of this compound. Okay. We have 4. Which is this 4? 4 what? Cyclohexyl. 4-cyclohexyl. We've gotten that. Okay, let's go to the next substituent, which is this. Okay, open a bracket. 4 also, bracket what? 2,2-dimethyl. 2,2-dimethyl what? Propyl. We close our bracket. Let's go to the next substituent, which is this. We have what? 2,2-dimethyl also. We have 2,2-dimethyl. And then we have another substituent here. This is 1, 2, 3. 5-propyl. 5 what? Propyl. And the longest chain is what? Octane. Let's explain this again. We have 4-cyclohexyl. This cyclohexyl substituent is on carbon 4. We have 4,2,2-dimethylpropyl. This on this carbon 4 we have a substituent. And what is the substituent? 1, 2, 3. Propyl substituent. On this propyl substituent we have 2 methyl. We have 2 methyl group on what? Carbon 2 of the propyl substituent. And that is why we said 2,2-dimethyl propyl. This 2,2-dimethylpropyl is on carbon 4 of the longest chain. Apart from that, we also have 2,2-dimethyl. That is here. On carbon 2, we have what? On carbon 2, we have another 2 methyl group. 2,2-dimethyl. And then finally, we have about 5-propyl. On carbon 5, we have another what? Propyl. The longest chain is what? Octane. Therefore, the name will be 4-cyclohexyl, 4,2,2-dimethylpropyl, 2,2-dimethyl, 5-propyl octane. It's a very long name. So you can actually see with me that naming compounds is very simple. Only what you have to do is to follow the rules carefully. You don't jump into naming compound from anywhere. Check your longest chain very well. Look at the substituent, and then you will name any compound in organic chemistry. So in today's class, we've learned how to name alkanes, cyclic compounds. We also know the rules that to name a cyclo, you have to prefix the name with what? Cyclo. Then there is no need to give the ring a number if there is only one substituent. We've also known how to name some of the some cycloalkanes here. And I'm very sure that if you have been following me from the starting of this class to the end, you should be able to name any cycloalkane at all. Thank you. Make sure you keep on following our channel. In our next episode, we'll be talking about bicyclo alkanes. Thank you.